All right. Hello there, dear YouTubers. My name is uh, King1993 Gaming or Mr. Colorless King. So, if any YouTuber or colorlessking.info website visitor are visiting this, okay, this will be today's topic will be about the sixth dimension of the CKDM model. Okay, so what is the sixth dimension of the CKDM model, or what is any of the dimension of the CKDM model is? Go to my YouTube channel, which is KING1993 Gaming, where I normally upload video of gaming, but I have made a separate playlist for this topic. And if you are not sure what the CKDM is, you can start with the negative 4 dimension and then go towards the positive 5 dimension. Then you will be able to learn most of the topic eventually. But for any of the viewer who are starting from this place, I will not explain all of the topic from the before. I will move on from the positive 5 dimension to the 6th dimension. Okay, so without further ado, let's get started. Now here's the thing. In my today's video, as I have already said, I will be explaining about the positive 6 dimension plus, okay, plus 6 dimension. So what is the plus 6d of the CKDM is about? Okay, so to understand this, we must first need to understand what my 5D was about. In my previous video of positive 5 dimension, I actually talked about the topic of something like uh, internal atomic information resonance, IR. Okay, so what is this mean? It means that atom has the capability to do what? Once we moved on from the fourth dimension, which is omnidirectional surface level atomic resonance, then obviously in the fifth dimension it is going to be internal information atomic resonance. So today's topic will be about this 60. So in the 60, I will try my best to give you guys a demonstration why do we have different imaging on an let's say MRI, X-ray, or different type of machine. Okay, so we need to talk about that. Okay, so first thing is when we talk about medical devices, okay, how many medical devices can actually allow us to see the inside and how do they react? So there are 5 machines that can actually help us understand MRI, and there is PET scan, and there is ultra ultrasound, MRI, PET scan, ultrasound, X-ray, and finally last one is uh, CT scan. Okay, where I basically said that X-ray and CT scan are very harmful. PET scan is you need to be injected with certain fluoride 18 to see the reaction with the machine, and then eventually there is ultrasound and there is MRI. These two are considered as the safest, except ultrasound is safer than MRI because if you have a certain metal inside your body, then MRI is going to cause a huge amount of pain because it is like a very strong magnet, and this MRI machine, magnetic magnetic resonance imagery, it basically records the data from inside by vibrating the magnetic machine in a certain way. Okay, so the question is, why does this matter? Why does this matter? So this matter because when we think of a ball, okay, so let's assume that this is a ball. I'm gonna color this completely black. So when you think about this ball, what do we usually think is that the ball inside are completely blocked from everything. The question is it really true or not? It is actually not true. The ball is not completely blocked. It is receiving energy. The energy it receives on the outside, by the time it goes inside, it is a lot less. Okay, so the question is, okay, why does this matter? This matter because in the plus 5D, where I talked about internal atomic resonance, internal atomic information resonance, in 6D, I will talk about why do we get different result in the uh, 5D, like internal atomic information resonance, like why do we get the difference? Okay, what do I mean to say is, imagine you try to get something like what should I call them? Let's say you do an X-ray. Let's say an X-ray, right? If you do an X-ray, you will eventually see that an X-ray is a machine that allows us to see the inside of a human body. But here is the thing: the bones and the skins are shown at different color. Okay, rather the X-ray machine only allows us to see the bone a lot more clearly than anything else. Okay, so this is X-ray. Now there is PET SCAN. Then there is PET scan. So what does a PET scan does is basically they inject a certain thing or a certain metal inside our body, fluoride 18, and then after the injection goes to their places, a machine, the PET scan machine, then scan the area to see where the liquid, not liquid, where the metal fluoride 18 has gone into. Now there is ultra SOU and the ultrasound. So in ultrasound we can see the inside not very clearly compared to the other, but it is the safest because it is often done on a pregnant woman, or let's say heart or maybe liver scan to check the internal component of the human body without damaging them. Okay, so this is like the internal baby, or let's say ultrasound. I did an ultrasound test on my heart. Ultrasound heart, ultrasound heart scan. So this is basically allows us to see if the heart is working properly or not. I did this because I take steroid to as testosterone replacement therapy, so I need to check my heart sometimes. So all of this machine does what? It allows us to see the internal. Okay, so the question is, why can we see the internal of the heart and many other things? So rest of the other machine can do the same. But the question is, why are we getting the data from this? Okay, how does the concept of data function work when we use imaging devices? So how does it work is, first of all, when we know the concept of uh, five dimension, which is internal in internal atomic information resonance, it means the resonance of the machine, the resonance of the MACHINE in the machine itself is resonating with what? The measurement body. So let's say the measurement body is my body, and the machine is doing what? It is creating a resonance pattern with the body. Okay, and then as a result, it is retrieving the data just by hearing a certain frequency or a certain sound. Now, when I talk about frequency, I'm not talking about any frequency. For example, ultra ULTRA, ultrasound. Ultrasound receives the data with mechanical vibration. Mechanical vibration is the classical vibration that we normally see with the human eye. Okay, this is classical. But here's the thing: X-ray or PET scan or MRI and another one, CT scan. All of these four devices, they are basically quantum. Quantum mean they still produces a type of vibration, but the vibration is basically hello. So the vibration is basically like quantum. Like, we cannot hear them with our ears, but we can hear them with uh, with sophisticated devices. Okay, so for example, when we do X-ray on the measurement body, okay, let's say my body is the measurement body, then what happens is it sends data directly like this. Okay, the data passes through, and eventually on the opposite side there is some sort of another device to receive the data from this X-ray and see how much data was absorbed by the uh, measurement body and how much was absorbed by this area here. Okay, so every time we can see that when we talk about X-ray, what we can see is when an X-ray happens, we actually see the bones a lot more visibly than the other parts of the body, which has a lot more air. So here's the thing: if we talk about this, then what is this? This is called thermodynamic variance. Okay, so atom, right? Atom, atom has what? Different atom melts at different uh, energy level. Okay, so let's say ice. Ice is made out of what? Water and hydrogen, but extremely cooled. So this is ice, right? And ice cooled about how many degrees Celsius? Is about uh, over over uh, one over 0 degrees Celsius, which is from, let's say, from 1 degree Celsius, the ice will starts to melt. Okay, and when it comes to iron iron has a much higher melting point. Okay, so let's say I will be writing here iron melting point. So iron melts at about 1538 degrees Celsius. So if iron melts at 15 degrees 38 Celsius, so what does it mean? It means that the reality in the simulation hypothesis, let's say the creator, Creator, creator of the simulation hypothesis created a different atom from atom 1 to let's see how many uh, total periodic table elements. Total periodic table elements is 118. So the amount of total uh, atomic classification is from 1 to 118 is the maximum that has been detected. But here is the thing: how many of them are artificially made? Artificial element number are, okay, 24. So out of 118, there are about 24 which are made artificially. Okay, so here's the thing: if we minus 118 with 24, we get 94, right? So out of the total 118, there are 94 of them that are found naturally in the atmosphere, or the human existence on earth. Okay, we can see them eventually. So the creator of the simulation hypothesis created about 100 and, sorry, 1 to 90. How much was it? About 90. Where is it? Okay, here it is. 118 minus 24. So the creator of the simulation hypothesis created about 94, 1 to 94, total 94 amount of atoms, and each of these atom has different variance. Okay, so when we measure the human body, let's say using this x-ray we measure the human body, what will happen is the x-ray will resonate with what? With the human body, the most uh, what should I say, the part of the human body that will absorb the most energy is going to be like the bones, right? So the resonance will first happen where? On the bones a lot more than it will happen with the water 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 content of the body. So it will resonate less here. So as a result, what will happen is the bones will show a lot more than it will show the water, which is why when it comes to X-ray we can see the variance. Okay, so in this case we know that atom has the capability to see into the human body, which is the 5D plus 5D, which is called, which I call it information atomic information, or internal atomic information resonance. 6D I call it uh, variable variable internal atomic resonance. Okay, variable internal atomic resonance. So what does this mean? It means that it doesn't matter whether we are looking at the data either externally, such as the 40, which is omnidirectional surface level atomic resonance, like being able to see all the side of a 3D object at a time. Not only can we see the variance outside, okay, but we can also see the variance on the inside. So the question is, what does this variance mean? Now, if you go back to my topic of the maybe positive 2D or maybe positive 3D, where I stated that quantum detection is something like detecting the vibration first. Okay, what does it mean? Allow me to explain. So, when it comes to quantum mechanic, okay, the first thing we often see is that when it comes to color has a certain vibration rate. When it comes to touching something, it has a certain vibration rate. And when it comes to even seeing things, like seeing with the human eye, even this all these three has what? The ability to detect an information that is below the human scale. But all of them are different type of vibration. So from this point of perspective, we can guess that the vibration is part of the natural process. And because of this reason, I name the 60 as the variable factor. It doesn't matter if the information is being detected on the surface of the ball. Let's say this is the surface and this is the internal. So 60 is like, I do not care. 60 is like, I do not care if you are the surface or you are the internal, because I will be able to detect the variance with you with thermally in any situation. And this is the reason why I call this the 60. Okay, so here is the thing. If we uh, look back on this topic here, remember, this is not something I made it my with the using of AI. I just pasted my paper and told it to explain my 6 dimension properly, and it did. And there are some way which I will be able to help you guys understand the topic even better. The 6 dimension operate as the energetic threshold layer, determining why identical material exhibits information output under identical condition. So this is what I was trying to say, that the reason we can see the difference in the measurement device, such as the 5 medical devices which allows us to see the internal of the human body, internal of of the human body. 1 minute please. Okay, but the question is, why can we see them? Because it is another property of the atom, that the atom, let's say that this is the measurement device. Okay, this is the measurement device and this is the measurement body. So what happens is, when the measurement device is measuring the measurement body, it is receiving the information back either on this side, or it can receive back with itself. Okay, for example, if we look at color detection camera, sorry, not color detection camera, uh, color sensor, color sensor device. In the color sensor device, uh, what happens is, color sensor scanner, sorry, SCANNER, color scanner sensor. Okay, here is the thing. So when we try to detect scanner, sorry, detect color using scanner, what does the scanner see? The scanner sees what? A certain frequency. If the scanner sees a certain frequency, then what will happen is, it will only give us data on those topic. Color scanner sensor, color sensor. Okay, color sensor, I think. Anyway, you get the point, right? Like how a device will basically I do not know the other one. Like, I think I have one. Let me check it. Okay, let's see. Okay, somewhere around here. No, not this one. Okay, not that either. Ah, here it is. So the color sensor device. So what does it do? When you put it on top of a certain color code, it will basically say what color it is by seeing which frequency is not bouncing back, and they can eventually assume which color it could be. Okay, so the similar thing happens with the X-ray as well. When the measurement device is reading the measurement of the measurement body, it is receiving a feedback, and the feedback is with what? With vibration. Okay, so and that is we know what it is. So what does it do? It basically allows us to see the different parts of the body. Okay, now how does this consider as a dimension? Okay, allow me to explain. So when we talk about dimension, when we talk about the word dimension, we often say that dimension will either be let's say x or xy or xyz, and then uh, the z allows us to see all side, something like this, a 3D cube. Okay, this is how it is measured when I say the concept of dimension. Not just me, anyone. But here's the thing, the word dimension itself is a vague word. Okay, the dimension topic itself is a vague word. So the question is, how do we define dimension? It can be defined with axis, it can be defined with characteristics, it can be defined with many different ways. Okay, so in my CKDM 60, in my CKDM 6D, when I talk about dimension, I am not talking about axis, I'm not talking about a x I s, I'm not talking about axis, I'm talking about the characteristics of the atom. That the reason we can see the different variants of the human body is because this is the only thing that the measurement device can actually detect, a vibration of a certain frequency. Vibration of certain frequency is what we detect. So this is the thing about the 6D. It doesn't matter whether we are detecting something either from the inside or from the outside. Okay, what we are detecting is a difference of vibration for at every atom. So for every atom from 1 to 94, all of them has a different vibration amount. Okay, but after we try to produce a atom, okay, using different method, what happens afterward is we get decay. Okay, rather the decay happens from the atom called lead. Lead atomic number, LEA, lead atomic NUMBR. Okay, so every atom after lead, okay, so every atom after lead, which is 82, when they are heated extreme amount, what happens is they revert back to 82. So let's say organism was 118, right? And California, Californium, Californium atomic number. So the Californium atomic number is 98. So what happened is the person, organism, is basically the person who made the atom in Russian, a Russian person. What he did, he used Californium, Californium with calcium, okay, to make a total of 118, which is basically a combination of 98 plus 20. So what this person did, he combined two different types of atom, calcium which is 20 and californium which is 98, and then eventually make 118. Okay, so after taking it with extreme amount of heat, about how much heat was applied, I think it was about 402 billion. Okay, about 402 billion amounts of heat was applied with the with this combination, okay, and eventually it turned into this. But after the experiment was done, what happened was, I do not know what happened to the calcium, but eventually the californium, okay, the californium eventually turned back to 82. Okay, so the question is, what is happening in this case? I think what happens is that maybe every atomic number has a total natural amount of from 1 to 82. Afterwards, when we try to do anything with it, let's say we did turn 83, whichever atom it is after 82, after lead, we then heat it at extreme amount, then eventually after the extreme amount of heating is done, it will eventually turn into what? 82. So what does this mean? It means that every atom after 82 has a uh, temporary phase by which it is gaining an extra vibrational state, which every measurement device such as the plus 60, like every measurement device is made out of what? Atom. And atom receives the frequency of other atoms. So what does this mean? So if we say, okay, what is the frequency? Frequency is like a signal. What type of signal? Allow me to explain. So there is one electron going in this path from a light source. Another electron is going to this path in another from another light source. So people assumes that they are having a internal fight in this place, okay, and eventually they will get cancelled out. But here's the thing, that is not gonna happen. The characteristics of the electron is, electron cannot see the path of each other, okay, only when an atom is detected. So it is part of my 1D, where I said that in 1D a line can go completely straight until it interacts with an atom, which where it will absorb a certain amount, it will cause a refraction to certain amount, and it will cause reflection to a certain amount. So absorption, refraction and reflection, these are the three property where an electron when interact with something like another atom, it will basically go straight. Why does it go straight? It goes straight because this atom, wherever this atom is, okay, when it sends the signal is going straight. But when it is going straight, we need to assume that something, an atom will be there which is about several 100,000 kilometers away, but eventually it will go there, and that is where it will either get absorbed or refracted or reflected, okay. So when I say that atom such as after 82 every atom turns back to 82 is an indication that maybe the measurement device can have a maximum resonance of about 82 properly. Afterward, any type of resonance a measurement device does with any atoms, so let's say after 82 is 83 to 118, okay, what will happen in this case? It is getting a false result, okay. So the thing is, if we talk about the electron shell of an atom, the maximum electron shell of an atom is up to 6 shell. But if you can force in a lab, such as how californium plus calcium was converted to oganesson, which is 118, in such case what happened is, we had to take the electron, neutron and the uh, proton capability from the atom itself and then produce this 118. But when an extreme amount of heat was added to it, eventually the reality caused it to turn it back to 80 82 again. But during the process, what was detected was in the measurement device 118. So what it basically means that maybe after a certain limit there is no such thing as 83. What this 83 could be is an information bias, not from the human being but from the machine. Okay, so let's assume something important. Let's assume that the machine is a machine. A machine measures something. Okay, but if the machine is measuring something but the something is not proper, not proper, is not proper, then what does it mean? Is it the machine's fault or is it our interpretation is the fault? Majority of the time it is our interpretation is the fault. Okay, so we need to be careful here. So when I say that the machine itself cannot maybe tell the difference between 82 versus 83, then maybe what could be happening is that we call it decay, right? That maybe a decaying happens which basically causes whatever atom there was, maybe a hydrogen, let's say. So what might be happening is that maybe a hydrogen atom moves away from this area of 83 number atom and then eventually turn back to this one. Okay, so why am I saying this? I'm saying this because if we look at hydrogen itself, it is have what in the first shell, shell 1, it has only one electron, which is why we have often seen uh, things like H2, for example, dihydrogen. So what is dihydrogen? Dihydrogen is something is not impossible, but there is a lot less of it because hydrogen is very unstable and it binds to every other thing. But it can, in certain context, in extreme amount of coolness, it can bind itself. So as a result, what you will see, a hydrogen with in the atomic shell 1 there will be two electron. So what does this mean? It means that the extreme coolness outside of the planet Earth, the coolness can actually cause the hydrogen to bind to itself to produce deuterium. This is what people call it deuterium, which is basically like hydrogen two atom combines. Okay, and is it radioactive? I actually do not remember. Is deuterium is deuteri deuterium is deuterium radioactive? Deuterium is not radioactive. Okay, why is it not radioactive? So maximally what I have seen, majority of the time, the radioactiveness often seems like after 1 and 82 totally depends on how much information is actually there, and they are not the type of proper information we should be asking. Maybe unlike these two, from 1 to 82, the rest of the other atoms that are basically in the 33 to 118 are not actually real atom. They are basically like a combined state. Okay, they are basically like a molecular reaction at the quantum scale, which is why the measurement device, what does it do? It does not seems to understand the difference between what is after 82. Maybe what happens is the frequency, as I already said, variable frequency of the 60. What happens in this case maybe is that the atom, the measurement device, okay, measurement device atom resonates with the 83, but it cannot tell the difference between 33 and 32, like 1 to 32. It cannot tell the difference. As a result, what happens is that maybe what is actually the truth is any atom after 82, from 83 to 118 are not real atom. They are might be a molecular bonding which the measurement device confuses, which the measurement device confuses as a real atom, a real atom. So this is where I am saying that the thermodynamic invariance is basically like it detects anything. Okay, so let's say you take anything inside your body, and this anything it detects as atom, because it can detect anything as atom as long as the atom are actually there. It does not detect the void and say there are atom there. No, it detects the atom, and as a result it says there are atom there. But how much the measurement device can actually tell what type of atom they are after 1 to 82 is the confusion zone. And I think radioactiveness is basically like put if you forcefully put if you forcefully put extra electron, you are going to get improper result. So this is what might be happening, because according to my theory of CKDM, uh, electron are not real particle. They are not real particle. Electron is a signal that an atom sends to another atom. Electron is a lowest amount of signal that an atom sends to another atom, and this is what the electron is sending. What is it sending? Signal. And when an electron is sending signal, let's say this electron is coming from light that is going here, and this electron is coming from another light that is going here. So even if they cross this path continuously, they are not gonna hit each other, because they are like signal. They the signal gets from atom A to atom B instantaneously, and they actually each of them have their own path, and their path do not collide unless atom A and let's say C are near each other. Only then their frequency might interfere against each other. Otherwise, if A and C are very far away from each other, and atom A is sending the signal to atom B, whereas atom C is sending signal to atom D, this middle area, they might cross each other, but they will not get affected, because information does not seems to care with path, which path you are taking, as long as there is no atom in this place. So from that point of perspective, when I say 6D is basically the thermodynamic variance, thermodynamic variance for every atom, what I meant to say is every atom from 1 to 82 has different atomic atomic resonance characteristics. But after 83, the measurement device do not recognize them as one thing, but because we are only getting the data from the measurement device, we suspect that 83 is a real atom. Maybe 83 is not a real atom, it is a combined atom. Okay, so you might be thinking, okay, how can I be so sure? So if we talk about molecule that produces radiation, molecule and atom produces are isotopes, okay, radionuclei. Okay, so let's say I talk about, let's say, the potassium, potassium uh, ra- radiation, potassium radiation. So when we talk about potassium radiation, we need to understand potassium radiation versus nor normal potassium. Okay, so here's the thing. Potassium 40 is naturally occurring weakly radioactive isotopes that makes out about 0.11117% of all natural potassium. Okay, it is primarily stable, both are chemically identical, but K emits beta particle. Okay, so what does this mean is, when we talk about potassium is never actually seems to be stable to begin with. So this is a different topic that I didn't understood. Maybe I need to put more effort into it. And potassium iodine, it is important to distinguish the difference between potassium 40 versus potassium iodine, which is a non-radioactive compound, can be found in thyroid, can be used to protect the thyroid from radiation accident. Okay, so what does this mean? If we just look at the data from this point of perspective here, is when we talk about potassium, okay, K40, when we talk about potassium, or let's say K40, K40 is naturally radioactive in banana. Okay, but here's the thing, banana potassium is not potassium only. So if we look at the data, is what uh, potassium siam uh, FORM form in banana. Okay. Okay, so potassium in banana exists primarily as soluble positively charged potassium uh, ions rather than pure elemental. Okay, such as potassium chloride, potassium sulfate, or organic, something like that. So what we are getting from that data is, when we talked about K40, okay, so the thing about K40 is it is naturally radioactive, but when combined with a different atom, it becomes stable. So as a result, we do not get the radiation. But here's the thing, if that is the case, that we get potassium as radioactive, but in the banana as stable, but when we burn the banana peel, okay, if you just burn the banana peel, then it will show radiation back again. Okay, it will show the radiation again, but when you do not burn the banana peel, it will show stableness. So the whether a certain atom is actually radioactive or not totally depends on whether you, we actually understood the measurement device properly or not. Okay, so in that regard, if any atom after 32 turns back to 32, sorry 82, not 32, 82. So if any atom after 82 turns back to 82, then it means that the similar thing can be happening just like it happens with potassium K40. Okay, so we need to keep that in mind, that maybe every atom that are basically after 82, after 82 are basically could be a molecular compound. Okay, they could be some sort of molecular compound that, when combined with another atom after 82, it becomes radioactive. And then when doing with extreme amount of heat, what happens is there uh, it causes molecular splitting, like H, like H 2O, dihydrogen oxide, right? So dihydrogen oxide, if we can give it extreme amount of heat, then what will happen? The oxygen will go away, and people assume that while oxygen goes away, it turns no, it turns to carbon. No, the carbon was there. Carbon dioxide is the heavy air. Okay, but when we are heating up the water molecule with heat, the heat contains carbon, and then the carbon takes the excess H, sorry, I mean O away. Okay, O away, and turn it to carbon dioxide, CO2, and the H2O O is gone, right? O is gone. Now what remains is H2. The H2 will then turn into hydrogen atom, and in the topmost layer of the earth they can turn into H2 by themselves. Okay, so what does this mean? It could mean that our understanding of the measurement device is something that we are not properly understood. Okay, the measurement device is something that we properly did not understand. As a result, we assume that, unlike my plus 60, where we assume that the measurement device is what it is getting affected, or let's say the measurement device is something that we do not understood properly, which is why we took the concept of variable thermodynamic resonance and said that, okay, that there are total from 1 to 92 atoms which are naturally found. Out of them, the 893 to 118 are artificially made. So I think this is the wrong concept, and the right concept is the actual atom of the reality is from 1 to 82. Anything after 82, they are not real atom. They are like molecular structure that is the measurement device do not realize properly, realize properly, and we take the only the data from the measurement device, and we think that maybe the measurement device is actually saying 83 to 118 is real, and we just put it in the book. Yes, we have detected new atoms. So that is basically how it goes. I don't think this concept is real. So this is what I think. Okay, this is part of my hypothesis. Now, the next topic is empirical validation through imaging technology. Okay, I just explained this topic, like different parts of the human body has different way of seeing. Thermodynamic ceiling. Okay, okay, I'm not gonna explain this one because even though it is written in my paper, you will not be able to understand what this topic C is. Right now I will skip over. I will explain it in my 15 dimension. Okay, magnetic phenomenon, thermodynamic resonance. Now here's the thing. I think I made a video of the Curie temperature motor which I have created by myself. So here's the Curie temperature motor, and I then used this to convert it into color. So Curie temperature motor, like I apply cold from the bottom. This is a metal, this is a metal holder, and this is a very strong powerful magnet that will try to get the metal get attracted to the magnet. So if you apply cold to the bottom part and then apply heat to the top part, then eventually what will happen is the metal will slowly rotate, and the cool part will try to go up and the heated part will go down. So what does this mean? It means this is the Curie temperature motor. Okay, but Curie temperature motor, Curie temperature was the concept, and then I took the concept and I made this into an idea of what the Curie temperature motor could be like, and this is exactly how a planet rotates around the sun. So when we say that the planet, okay, let's say this is the sun and this is the total 8 planets. Okay, when we say the distance of each planet are as follows: uh, Mercury, Venus, Venus, Mercury, Venus, I do not remember properly, Earth, Mars, then Saturn, then Jupiter, whatever it is, Uranus, and then Pluto. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so all of them I have named. So why are they in their own distance? Maybe due to the thermodynamic balance of themselves, they just move to the proper position where they can stay near the sun. But while stay near the sun, based on their elements, they position themselves in different orbital zone to make sure that they do not get extremely heated and eventually break their molecular bonding. So maybe this is the main reason why the thermodynamic variance happens, that the creator of the simulation hypothesis, so the of the simulation hypothesis created a measurement system that any measurement devices will basically detect every frequency as an individual frequency after 82. So as a result, we are actually getting the wrong formula all the time. So is there any way to fix this? I do not know, but I can definitely say the creator, which I call it the God Almighty, intentionally created this so that when we only take the data from the from the simulation hypothesis, it is just to fuck around with the mind of the scientist, which I do not mind, because after all, we are living in a simulation hypothesis where we are getting constantly being recorded with our characteristics, and the God will say, I am going to judge you based on how you thought. In this case, I will never say, let's say, bad words to the creator, which I call it in my religion, the God Almighty. But to many of the scientists, this might seem stupid, because how can I say this? The measurement device definitely reads a data of 83, like above 82. Then how can I say that it is not true? It is not true. I am saying this because if anything after 83 goes back to 82, okay, or let's say anything from 118 to 83 goes back to 82, then this means that these are not real atom. They are called uh, fuck around with the scientist atom. These are called fuck around with the scientist atom. These atoms are created by the creator of the uh, simulation hypothesis to say, I intentionally created this mechanism so that the measurement device will always give the correct answer according to the scientist, and say we detected a new atom, but in fact what we actually detected is not atom but molecule. Molecule, molecule. Okay, you get the idea, right? So this is exactly what I think is happening, that the creator of the simulation hypothesis after 82 made sure that any measurement devices that we try to detect this with is going to have a different result. But the scientist will take the data only and say, look guys, this is 80 after 82 are real atoms. We can categorize them as atom, but in reality when they get separated, like how I explained the oxygen, like H2O, like how I explained this, how they get separated, this turned into carbon dioxide, and this turns into H2, or just normal H. Okay, so this is how the after 82, when they get heated, let's say 83 gets extremely heated, what will happen is whatever was sticking together with it, whatever atom, let's say, I think maybe that after 82 plus one hydrogen atom, this is what 82 is. Okay, this is what I think my hypothesis is saying, uh, that uh, 83 atomic atomic number. Okay, so bismuth, what I think bismuth is basically is basically an atom that is in the category of lead, but because the amount of hydrogen inside the bismuth, which is about 1, is trying to stay together in such a way that they do not want to shape a proper form. Like you can always melt bismuth and they will always form this. Okay, but if you melt a lead, lead, 82, you can basically mold lead into your whatever way you want them to, but you can't do the same naturally with the uh, bismuth. So this is what I think is happening, that when we say that the bismuth, like why is a magnet, a magnet uh, or let's say, okay, let me draw it in the bottom. Okay, let's say this is a magnet, a powerful magnet, neodymium magnet, and there is a bismuth block, small. Why do they not get attracted? Due to the same reason as the what should I call it, the water. Like when you take a table, okay, a glass table, and you put water here, remember this is water, and then you take the powerful magnet and slide it here a little bit faster, let's say about 1 to 2 kilometer speed, then eventually what will happen is the water, it will move like a wave and move backward. The same concept is appearing here, like maybe maybe the magnetic field, when attracted to the hydrogen, which cannot be differed, because it must need to be separated with extreme amount of heat, only then it becomes lead again. What is happening is lead is already uh, non-magnetic, right? And when lead interacts with hydrogen, it turns into 83, and the measurement device can't tell the difference. Measurement device can't tell the difference and says, why is bismuth acting the way it does, where when it comes to hydrogen, or let's say even water does the exact same reaction. So this is my hypothesis, that maybe what we are saying is that we never understood the measurement device itself properly. If we never understood, okay, the measurement device properly, then it means many of the measurement that we made is actually incorrect measurement. Because the reason I'm saying this, the thermodynamic variance of the plus 60 is atoms, according to my circadian theory, is never destroyed. From 1 to 82, not a single atom can be destroyed. Okay, so when we say that we are looking for subatomic particles such as electron, or muon, or tau, or proton, or neutron, we are forgetting what these truly are. Maybe they are signal. This signal is about whatever amount it is. This is about 200 times larger, 200 times larger, and this is larger than the rest of the other. This is larger than proton and even neutron. Okay, so what we are actually detecting is signal. So signal is basically like electron can produce a maximum of a 1 electron equivalent amount of signal from atom A to atom B. But a muon is basically like about 2 electron equivalent amount of signal sent from atom A to atom B. Okay, so let me check how much uh, uh, how much B BIGGER bigger is the mu on than electron. Okay, not muon. Muon is 200. That much I know is tau. How much is it? It is about 3,500. So uh, it is like a tau is basically equivalent to saying about 2,500. Was it 2,500? Okay, sorry, 3,500 is equivalent to about 3,500 electron equivalent amount of signal being sent from atom A to atom B. So in this way, electron, muon, tau, proton, neutron, all of them are basically a signal amount that they can actually send from atom A to atom B. Okay, so this is my hypothesis. So using this hypothesis and the hypothesis of the element from 1 to 82, they have a certain frequency of information type. So after 82, the frequency from 83 to 118 becomes unrecognizable because their frequency overlap with one another. So if you can already detect a certain signature amount from this atom here, which is lead, 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 and you are getting another information from let's say from one extra hydrogen atom, maybe the measurement device, whatever the measurement device it is already overloaded at 82, and then the extra one creates a bismuth. So when heated at extreme amount, the bismuth will lose its extra hydrogen, will become less reactive, and then turn to 82. So this is an important thing that I must need to say. Okay, now let's move on to the next topic. That is okay, magnet. Okay, so in this case, the thermodynamic resonance, that is that in this case, if this was a different type of metal, obviously the amount of heat needed is going to be different. Okay, now atomic pole reversal and thermodynamic correction. So I already explained this, the poles, not the poles, like how each planet is on their different position because of the thermodynamic variance, and this variance tells them to stay where they are. Okay, so it is like a push energy, but what this push energy is something that I will explain in my 12th dimension. So let's move around a little bit to with this diagram. So allow me to explain a little bit to give you guys an intuition. Okay, so this is a ball. In this ball I have placed atoms. Okay, so three types of atom I have put here: gold, iron, and silver. So black ones are iron and the white one are silver. Okay, so what is happening is they are in a state of Brownian motion. So think of this, there are total 33 amount of each of the element. Okay, 33 gold, 33 silver, and 33 iron. So normally when they are near each other, okay, when they are near each other, they are gonna do what? They are gonna move in a Brownian motion because they are constantly receiving energy from the environment. Okay, even though they are inside a ball, the idea that energy, that 5D plus 5D is being able to see the inside of a 3D object, and plus 6D retrieves the information from here to a device that can be either in this place or bounces back. Okay, then what it means that normally the 3D object is constantly receiving what? Receiving information from the surrounding at a certain amount. But when we use the measurement device, let's say X-ray, we detect it with X-ray. So what will happen? Let's look at the intuition here. So this is the Brownian motion of 33 33 plus 33, total 99 atoms put inside a ball, and they are in a state of Brownian motion. When they are near each other, they are gonna bounce, and when I am moving them, they are uh, trying to bounce off to get out of the ball, but can't because the ball is stronger than the individual atom, and then they are in a state of Brownian motion. But what happens if I turn on the frequency gun on? Let's say the X-ray. Now they are going to vibrate even more. Okay, so they are gonna vibrate even more. And what does this indicate? It indicates that the concept of measurement, that by measuring something, okay, you are automatically causing an effect with the device. And sometime the measurement device, even though it is one way, the way the device itself is working is a little bit different. For example, when the concept of organism, when the concept of organism 118 was created, the measurement device was just a normal detector, okay, not an X-ray. So the normal detector was detecting what? 118. But the organism atom, which was done with the help of what? Californium plus calcium 20 plus 98. How was it done? It was done with extreme amount of heat, and the heat was about 402 billion. So in such temperature, the measurement device maybe got affected by the temperature itself, and then at a certain temperature it detected this. So what might be happening is, when we are measuring the measurement device, with the help of the measurement device, when we are retrieving the data, we are constantly interacting with the data itself of the atom, or maybe we are already putting too much plus 60 thermodynamic effect within the organism atom, which is about 402 billion degrees Celsius, to make them combine together to turn organism from californium and calcium to organism. Okay, so this is the thing, that when maybe look what happens when eventually the signal overlaps. So when the signal overlaps, we cannot tell which exact atom it is overlapping, unless we are only looking at the gold one, or the silver, or the let's say the iron. When the iron and the silver are vibrating near each other, we cannot tell the difference which one is which. But because the gold atom, I have intentionally given it a gold color, we can say, okay, the gold color is definitely the vibration of the gold atom. But when it comes to the atom color difference of the uh, let's say white, the silver one and the iron one, we cannot tell the difference easily. If we slow it down, we can see it, but it is not the concept of slowing down, it is the concept of the act of measurement. Like I am using a frequency gun, such as the, let's suppose, X-ray, and I am trying to move it, and this is what is causing the result. We cannot tell which vibration is which if we concentrate them in within one zone. We cannot tell the difference. So this is the thing, that maybe the measurement device cannot tell the difference. If the amount of vibration exceeds the measurement device itself, only then the measurement device just say, I am detecting an average of 82, more than 82. So if I am detecting more than 82, then it can be between 83 to 118. Okay, so resonance capacity, as I said, different atom has different resonance capacity, which is the Curie temperature. But here's another concept, which I will not talk about here. I will talk about in my 11 dimension, because my 11 dimension will talk about why thickness matters. Thickness is basically the same topic here, same, except I will allow the concept to be more clear and intuitive in my 11D. Okay, now, epistemological implication constant as thermodynamic filter. The six dimension epistemological this and that epistemological expression. What can be okay? Record matters. Constrained by, okay. Okay, so eventually, what I am saying, that when we are talking about the reality, we need to be very careful of my CKDM dimension. My CKDM plus D is basically saying the act of measurement causes the change within the atomic device. Okay, and if we try to gather the data using X-ray and look at the atomic inside, we are causing cause and effect to the atomic information itself. Okay, and normally in physics we already know this time is true, but I need to use intuition, which is why I'm saying that even though we know quantum mechanic wise this topic is true, that the act of measurement causes the information itself to get collapse, which is true, I still need to put it here. Okay, we know this, but we need to put it here, which is why I'm saying that even if we can receive the data from both the inside and the outside, the only way we are receiving the data with vibration and the quantum vibration, not just any vibration, quantum vibration. So when it comes to quantum vibration, we must need to know that with the human eye is detecting what? Vibration. Okay, so the human eye is detecting the vibration. Touch, the human touch capability is very low, which is why we need to use machine such as this one to say what color it is. Okay, if you go back to my 2D, in my 2D it is explained with more details. Okay, so the touch can be felt with what? If not with hand, then it can be done with device, and device can detect what? A frequency, which frequency is not being reflected back, and that is how the color is mentioned. And let's say any other, let's say ear, or let's say taste. Okay, okay, here is the thing. Quantum vibration, right? Quantum vibration. Eyes, which allows us to see. Ear, 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 allows us to hear. Nose allows us to smell. Taste, our tongue allows us to taste, and the skin allows us to sense. All of these are receiving what? Vibrational data. So when a quantum device is measuring something, a vibrational something, we need to remember that the human body is made out of what? Atoms. And atom receives what? Information with the eye. Hearing something with the ear, like hearing something with the ear. Smell something with the nose. Touch something with the hand. And uh, sense something with the skin. So all of these are what? Atomic characteristics. So if we think that our human body automatically done this, how can we say that the measurement device itself is separated from the measurement effect? It is not, which quantum mechanic people understand. But what I'm saying is, I specifically want to say that plus 6D of the CK DM model is used to what? Is used to say that we need to have an intuition model of this topic. Otherwise, if we just make random math, remember of my CKDM has a certain way of categorizing stuff, and that is what? That is the important part. We cannot just say, okay, where is it? Where is it? We cannot just say that we do the math. We do the math. We cannot just say we do the math. But no, why is doing the math first is not a very good intuition? Because if we have observation data, if we have repeated experimentation data, such as every every atom after 83 to 118 turns back to 82, we need to understand why it is happening. We make a logical conclusion, which I think my logical conclusion is a lot better than majority of the other mathematical peoples and the theoretical physics area. And then we make math out of that topic, and then if we do the the math does not match with the reality, then we re-evaluate the process. So I think with the observation that I have seen, repeated experiment that I have heard, and the logical conclusion I have made about how the atom from 1 to 82 are actually atom, and anything after that are not atoms. They are basically not even isotopes. They are basically like what should I call them? Molecule. I think that is the proper equivalent amount of saying that maybe I understood something a little bit deeper. I'm not saying this is the only truth. I'm saying this is something deeper that we must need to investigate. Okay. Now I have finally come to 114 minutes. I think I repeated the entire topic again and again. Sorry about that. But this is the whole thing. Now today the diagram was not that much, but at least I was able to give you guys an intuition that maybe anything that we can detect after 1 to 82, they are not atoms. They are atomic resonance, where the resonance of, let's say, vibration, like, right? Okay, so eventually let's say that I create a wave. Okay, let's say this is a wave. This is the wave of uh, californium, and there is another wave overlapping with each other. This is the calcium, Ca calcium. So what will happen is, maybe the eventually what is happening, the measurement device is measuring this area here, and eventually saying we have detected a new atom that is 118, not a combination, not a combination of 98 98 plus 98 plus 20. This is what the measurement device cannot say. It says that I have detected something here or something here, and this is how we are getting the data, and eventually says that 83 83 to 118 118 are real, which is I don't think it is. Okay, so that will be all for this topic. Next time I will be talking about the positive 7D, but that will be a different day. So if you find this topic useful, then please give a like and subscribe and click the bell notification icon if you are interested in this specific CKDM model. Okay, so goodbye, stay safe, and see you again next time. All right, I needed to add one more topic before sending the video on YouTube, and here's the topic. That is, I have made another chart so that you guys will be able to understand. Now look at this chart carefully. I have given it a different instruction. So what I am hypothesizing is happening, or theorizing what is happening, so allow me to explain. So let's say this is atom 1, which is hydrogen, which will have something like this type of way, and this is element 2, whatever the element 2 is, which is helium, and then so forth. So eventually when we go to 82, it will get already extremely very noisy, right? So the machine detection, okay, so the detection machine, which is a, remember that every machine by default is quantum machine by nature. So when the machine after 82 recognizes another atom which is 83, what might be happening is something like one extra atom can be felt. So the point that all the element after 82 returns back to 82 is an indication that if we can make a atom 118 organism and say it is a new atom, but it is a combination of californium and calcium. So californium and calcium, which is 98 plus 20, can be added to make this. How can we even say that this is an a new atom? It might be a something which falls into the new category. Imagine when we detect 83, we say it is the next material after lead, lead. Okay, but what if whatever we are detecting here has been in the same situation as 118, where a hydrogen atom, oh, this is bismuth. Okay, so lead, lead, lead plus one hydrogen atom, or Pb plus H. So Pb plus H, if this can combine to make bismuth, bis m u t h, bismuth, then automatically we can assume, if this is true, californium plus calcium is, if it is true, this is organism, then how can we not say that bismuth is basically lead plus hydrogen? This is the main topic that I am thinking, that maybe what is happening is, after 82, after 82, not a single atom is real. So let's say when I am going up to 82, we can already see that the measurement device is at its maxed capability. Now, if we use 83, then what will happen is we are going to read in between the line, and if we can read in between the line with the machine itself, so what will happen is the machine itself will detect a new type of frequency. Okay, so basically speaking, one frequency getting absorbed by the another frequency is eventually going to overlap. Okay, if a overlapping frequency happens, this area, that is, then how can we say that this is a new frequency when it might be a combination of hydrogen and lead? Okay, so if we were to add 118, we can get something like this. If we get something about like this, then how can we say that it is a new atom when we can definitely know that californium and calcium are basically two different type of atoms? So we need to be very careful in when we say that uh, it is a new type of atom. Maybe what is happening, the machine is unable to detect that. Okay, so allow me to explain. Telephone line problem. Okay, let's see. Telephone, WHISTLE, whistle, PROB, whistle problem. So in the old time, there used to be something like this device. Okay, back when the telephone was like something like this, there was an issue where a signal or a here it is, a vibration from this would automatically cause confusion with the, what should I call it, with the dial device. Here it is. In the 1960, a toy whistle from a Cap'n Crunch cereal box accidentally blew the same tone used by AT&T phone system. Hackers realized it could be unlocked free long-range calls, sparing the era of phone pricking or freaking and costing AT&T millions. So this is a real topic. So if the machine itself cannot tell the difference, but we have to make algorithm to tell them what it is real or not, then how can we say that when we are detecting real atom, we are actually not confusing the two state of matter after 82, and then we are saying, oh, it is a new type of atom. Okay, so this is the thing that you will be learning here, that with proper intuition of the model by interacting with the internet and gathering data from multiple places, how can we actually say that all the atom after 1 and 82, 1 or 82 are real? They could not be real. After 82, they are all a new type of molecule. Okay, so I think there are two unique categories of molecule. One is just a chemistry based molecular bonding. Another is not chemistry, but some sort of new state like nuclear nuclear molecular bonding. Okay, so in the normal chemistry molecular bonding, we can tell the difference. Okay, but in the nuclear molecular bonding, which is not even nuclear, like two neutron getting together to make a new type of atom, no, not that. Like in extreme heat, what might be happening is the lower atom gets away from the, so anything above PB, which is lead, so anything after lead, whatever it is, when extreme amount of heat is applied to it, what will happen is whatever the atom was available with the lead is gone, and then lead is the only thing that is remaining. And from there we can say that the reason every atom returns back to 82 is because the rest of the atom are not even atom, they are a combination of between 1 to 82 to make a something up to 118. So this is how I think it is happening. Okay, so if you find this theory interesting, please leave a comment and like and a whatever it is possible to help my channel and to spread my CKDM topic. Please do so that we can be able to get even more good hypothesis idea in the future. Okay, so goodbye, stay safe, and see you again next time.